Hello everyone, welcome to this tutorial about integration. So we learned about differentiation, which is the reverse process of integration, and also we can say that integration is the reverse process of differentiation. So integration is applied in many disciplines such as area between curves, distance, velocity, acceleration, volume and center of mass, work probability, surface area, and many more. So in this tutorial, we are going to learn about infinite integration, the constant of integration, integrating a constant c, integrating cx to the power n, integrating a sum or difference of functions, integrating ax plus b, whole thing to the power of n. Infinite integration. When x square is differentiated with respect to x, the derived function is 2x. Conversely, given that an unknown function has a derived function of 2x, it is clear that the unknown function could be x square. This process of finding a function from its derived function is called integration, and it reverses the operation of differentiation. So we know that when x square is differentiated with respect to x, we get 2x. And as a reverse operation, what if we need to find out the inverse? Say the derived function is 2x and we need to find out the unknown function which gives us 2x when it is derived with respect to x. So this process of finding a function from its derived function is called as the integration. The constant of integration. Consider the function x square plus 1 and x square take away 7. So we have already learned that derivative of x squared with respect to x gives us 2x, which is you multiply by the power and take away 1 from the power. But look at the derivatives of x squared plus 1 with respect to x, and also the derivative of x squared take away 7 with respect to x. So the answers are 2x and 2x. So clearly 2x is the derivative not only of x squared but also of x squared plus any constant. Thus the result of integrating 2x, which is called the integral of 2x, is not a unique function but is of the form x squared plus k, where k is an arbitrary constant called the constant of integration. So as we are getting the same answer for derivating of x squared plus 1 and x squared take away 7 with respect to x, it is because when a constant is differentiated with respect to x, the answer is 0. So that is why we are getting 2x as the answer for both the derivatives. But when the reverse process is considered, so it is not possible to get an exact answer for the integral of 2x. So this is why we add an arbitrary constant with the integral, which is called the constant of integration. So this is written as integral of 2x with respect to x equals x squared plus k, where the symbols means the integral of the function with respect to x. As integration reverses the process of differentiation, for a function f of x, we have integral of dx of f of x with respect to x equals f of x plus k. So here we are getting the same function of f of x because the integration and the differentiation is done at the same time. So the integration is the reverse process of differentiation. So the integration and the differentiation get cancelled out by themselves. So we end up with f of x with an arbitrary constant of k. Similarly, since differentiating x cubed with respect to x gives 3x squared, we can say that integral of 3x squared with respect to x equals x cubed plus k. So we add 1 to the power and divide by the new power. We can also see the integral of x squared with respect to x as 1/3 of x cubed plus the arbitrary constant k. So where we have done the same process of adding 1 to the power and dividing by the new power. Adding 1 to the power would give us 3 and dividing by 3 would give us 1/3. So the answer is 1/3 x cubed plus k. But if you look at these two equations, By dividing both the sides by 3 for this equation, we get integral of x squared dot dx and 1/3 times x cubed plus k. So that is what we have got in this equation. So it is not necessary to write k by 3 as we are dividing both the sides by 3 in the second form, as k represents any constant in either expression. So the value of k can be anything. So we do not consider the exact value for the arbitrary constant. In general, since differentiating x to the power n plus 1 with respect to x gives n plus 1 x to the power n. So the reverse process would be integration of n plus 1 x to the power n. So which would give us x to the power n plus 1 as the answer. So as a general equation, we can say integral of x to the power n with respect to x equals 1 over n plus 1 x to the power n plus 1 plus k. So we have found the reverse process of integrating n plus 1 x to the power n, where we have divided both the sides by n plus 1. So the n plus 1 on this side would go to the other side as a denominator. So that is the general term for an integral of x to the power n with respect to x. So that is, to integrate a power of x, increase the power by 1 and divide by the new power. So we have added 1 with the n, which is n plus 1, and have divided by the new power, which is n plus 1. This rule can be used to integrate x to the power n for any value of n except -1, which will be considered later. So the integral of x to the power -1 with respect to x would be discussed later in a tutorial, as it is considered as a special case in integration. Example, integral of x to the power 7 with respect to x. So we add 1 with the power and divide by the new power, which is 1 over 8 x to the power 8 plus k. Integral of x to the power -4 with respect to x. Again, we add 1 with -4, which is -3, and we divide by the new power, which is 1 over -3. So the negative can be taken as a common to the fraction, which is -1/3 times x to the power -3 plus the arbitrary constant. Similarly, the integral of x to the power half with respect to x equals add 1 with the power, which is 1/2 plus 1, which gives us 3 over 2, and we divide by the new power, which is 1 over 3 by 2, and the 2 can be taken to the top, which is 2/3 x to the power 3/2 plus k. Integrating a constant c. The result of differentiating cx is c. So we know by differentiating cx with respect to x would give us c as the answer, because the power of x is 1. So you take away 1 from the power, which is x to the power 0, which would give us 1 as the answer. So the final answer would be c if you differentiate cx with respect to x. So the reverse process is integral of c with respect to x, which is cx plus k. You include the x with the constant and the arbitrary constant. Integrating cx to the power n. So the differentiation of cx to the power n plus 1 would give us n plus 1 c times x to the power n. Hence, integral of n plus 1 c times x to the power n with respect to x would give us c x to the power n plus 1 with k. So by dividing both the sides by n plus 1, we can get integral of c x to the power n with respect to x equals c over n plus 1 x to the power n plus 1 plus k. So if you consider only the integral of n plus 1 c x to the power n with respect to x would give us n plus 1 c, which is a part of the constant, and only the term with the x will be integrated. So which would give us x to the power n plus 1. So we add 1 with the power and we divide it by the new power, which is 1 over n plus 1. So the n plus 1 and n plus 1 would get cancelled off. So we get an answer as c x to the power n plus 1, which is what we have got here. And with the answer, we get an arbitrary constant of k. We do not get the constant of n plus 1 like what we have got in this equation. So the n plus 1 would be there as the denominator of the answer. So they both are actually the same. Some terms have been placed in different orders. Integrating a sum or difference of functions. It was shown differentiation is a distributive process across addition or subtraction. So since integration reverses the differential operation, integration also is distributive in this respect. So we have learned that differentiation is a distributive process across addition and subtraction. So as the integration is the reverse process of differentiation, so the same characteristic of distributive would be common to integration as well. So for example, integral of x cubed plus 1 over x squared plus root of x with respect to x would give us, so we change the denominator x squared as x to the power negative 2. So when the x squared goes to the top, it becomes a negative power, which is x to the power negative 2. And in addition to that change, there has be another change, which is root of x can be written as x to the power half. So as the next step, we can write it down with the distributed terms, which is integral of x cubed with respect to x plus integral of x to the power negative 2 with respect to x plus integral of x to the power 1 half with respect to x. So by integrating x cubed with respect to x, we get 1 by 4 x to the power 4, which is you add 1 with the power and you divide it by the new power and then take away x to the power negative 1. So this is because when you add 1 with negative 2, we get negative 1. So the negative 1 is divided. A common negative sign will be written in front of x to the power negative 1. Plus the integral of x to the power 1 half with respect to x would give us 2/3 x to the power 3 half plus k. So we add 1 with 1 half, which is 3 half, and we divide by 3 half, which is 1 over 3 half. So the 2 comes on top. So we get 2/3 x to the power 3 half plus k. Now try these questions by yourself. Integrate the following with respect to x. So the first question is integral of 2x squared take away 1 over x squared plus x with respect to x. So what we can do is we can distribute the terms inside the brackets into their additions and subtractions. So if you work out this question, you'll be getting the next step as integral of 2x squared take away x to the power negative 2 plus x with respect to x. So we get a negative power because the x squared, which is the denominator in this term, goes to the top, and when it goes to the top, it becomes a negative power. And now we can distribute the terms inside the brackets into individual integrals. So we'll be getting integral of 2x squared with respect to x, take away integral of x to the power negative 2 with respect to x plus integral of x with respect to x. So when we integrate each of these terms, the constants that are with the x term stays the same, and only the integral is done to the x terms. So if you consider 2x squared, the 2 stays the same. We add 1 with the power and divide by the new power, which is 2 over 3 x to the power 3. And then moving on to the next term, we add 1 to the negative 2, which becomes negative 1, and we divide by the new power, which is 1 over negative 1. So the common negative and the divided negative would combine together and become a positive. And then 1 add to the 1, which is the power of x in this term, becomes 2. So it becomes x squared, and we divide by the new power, which is 1 over 2. So simplifying this expression gives 2 over 3 x cubed plus x to the power negative 1 plus 1 half x squared plus the arbitrary constant k. So if you work out the second question, integral of 3x cubed plus x to the power negative 3 plus 3 with respect to x, we can distribute each of these terms into individual integrals. That would give us integral of 3x cubed with respect to x plus integral of x to the power negative 3 with respect to x plus integral of 3 with respect to x. Adding 1 to the power would give us 4. Dividing by the new power, which would give us 3 over 4 x to the power 4. Adding 1 to the power would give us negative 2, and dividing by the new power would give us 1 over negative 2 and x to the power negative 2 plus We do not have a term with x, so we have only the constant. So when integrating with respect to x, a term with x would be included. So that would give us 3x. So integrating any constant with respect to x would give us a term included with the x. So simplifying the expression would give us 3 over 4x to the power 4 negative 1 over 2 x to the power negative 2 plus 3x plus the arbitrary constant. Integrating ax plus b whole thing to the power of n. First consider the function f of x equals to x plus 3 whole thing to the power of 4. The derivative of f of x is found by using a substitution u equals to x plus 3, so that f of x becomes u to the power of 4. So when 2x plus 3 whole thing to the power of 4 is differentiated with respect to x, we get 4 times 2 times 2x plus 3 to the power of 3, where we multiply the power and take away 1 from the power, and also we have to differentiate the terms inside the bracket and multiply it to the final term. Conversely, integral of 4 times 2 times 2x plus 3 whole thing to the power of 3 with respect to x would give us 2x plus 3 whole thing to the power of 4 plus k, because that is the inverse of what we have done over here. So integrating only 2x plus 3 to the power of 3 with respect to x would give us 1 over 4 times 2 times 2x plus 3 whole thing to the power of 4 plus the arbitrary constant. Similarly, considering the general case where f of x equals to ax plus b to the power of n plus 1, we find that integration of ax plus b to the power of n plus 1 with respect to x would give us n plus 1 times x plus b to the power of n. Hence, the general formula for the integration of ax plus b whole thing to the power of n with respect to x would give us 1 over n plus 1 times ax plus b whole thing to the power of n plus 1 plus k. Example, integral of 3x take away 8 whole thing to the power of 6 with respect to x. So first we would add 1 to the power where the 6 becomes 7, and we divide by the new power, and we differentiate the terms inside the bracket, divide the answer also. So if we differentiate 3x take away 8 with respect to x, we get 3 as the answer. So we divide by 3 and an arbitrary constant is added. Integral of 2 take away 5x whole thing to the power of 9 with respect to x equals add 1 to the power which is 9, add 1 becomes 10, and divide by 10 and differentiate the terms inside the bracket, and dividing would give us 1 over negative 5, and finally we add an arbitrary constant. Integral of 1/2 take away 1/3 x whole thing to the power of 7 with respect to x. We add 1 to the 7 which is 8, and we divide it, then we differentiate the terms inside the bracket where we get negative 1/3. So we divide that also where we get 1 over negative 1/3, and we add the arbitrary constant. Now try out these questions by yourself. Integrate the following functions with respect to x. So we have 4 times 1 take away x whole thing to the power of half. So if you work out this question, the constant 4 stays the same. Then we add 1 to the power which is 1/2 add 1 gives you 3/2. We divide the new power and we differentiate the terms inside the bracket, and we divide that also, which would give us negative 1 in the denominator. And at the end we add the arbitrary constant. So simplifying this expression would give us negative 8 over 3 bracket 1 take away x whole thing to the power 3 over 2 plus k. So we have got the 8 on top because the 2 goes to the top and it becomes 4 times 2. The 3 stays as the denominator and all the other terms stays the same. Moving on to the next question. Integral of 1 over bracket 4x plus 5 whole thing to the power of 3. So we take the denominator to the top. So that becomes integral of 4x plus 5 whole thing to the power of negative 3. So when the denominator is taken to the numerator, it becomes a negative power. So integrating this function would give us adding 1 to the power, which is -2, and then we divide it. Next we differentiate the terms inside the brackets with respect to x so that we get 4, and we divide that also. And at the end we add an arbitrary constant. So simplifying this expression, we get -1/8 times bracket 4x plus 5 whole thing to the power -2 plus the arbitrary constant. So that's it for this tutorial. I hope you enjoyed learning about integration. So in this tutorial we learned about infinite integration, the constant of integration, integrating a constant c, integrating cx to the power of n, integrating a sum or difference of functions, integrating bracket ax plus b whole thing to the power of n. So in infinite integration, we learned that the process of finding a function from its derived function is called as the integration, and we found that integration is the reverse process of differentiation. Then we learned that an arbitrary constant needs to be added with the integral all the time when we work out infinite integration. Next we learned that the differentiation of cx with respect to x is c, so that the integral of c with respect to x is cx with the arbitrary constant. Then we learned the integral of cx to the power of n with respect to x gave us c over n plus 1 x to the power n plus 1 plus the arbitrary constant. After that, we got to know that like differentiation, the integration is also a distributive process across addition and subtraction. Finally, we found that integrating bracket ax plus b whole thing to the power of n with respect to x would be done by adding 1 to the power, then dividing by the new power, and differentiating the terms inside the bracket and dividing by the result also with an arbitrary constant. So we'll be learning about finite integration in our upcoming tutorial, and also we will work out more practice questions. So for all of that and more, I'll see you in the next tutorial. Thank you.